There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Today, we will focus on supervised learning. So, what is supervised learning? Supervised learning is a type of machine learning where a model learns from labeled data. This means that the training dataset contains both inputs or features and outputs or targets or labels. The goal of supervised learning is to learn a mapping function that connects inputs to their correct outputs so that the model can make accurate predictions on new unseen data. The algorithm identifies patterns in the training data and applies this knowledge to future predictions. But what does any of that mean? Well, let's better understand this with an example. Suppose we want to build a model to predict house prices based on house characteristics. We first create a dataset containing information about multiple houses. For each house, we include input features such as the number of bedrooms, the size of the house, and its location. But we also include the output or the target, which is the actual price of the house. By analyzing this data, the model learns how different features influence house prices. And once trained, the model can predict the price of a house based only on its features without knowing the actual price in advance. In essence, supervised learning means learning from labeled examples to make feature predictions. There are two main types of supervised learning, which are classification and regression. But what's the difference? Well, classification models predict a categorical target by assigning inputs to discrete classes. In simpler terms, the target we want to predict has a finite number of possible values. Whereas for regression, the regression models predict a continuous target, estimating numerical values rather than categories. Meaning that in classification problems, the number of possible outputs is limited. But in regression problems, the possible outputs are infinite. Here are some examples. So for classification, an example is a spam filter that detects whether an email is spam or not, or a cancer detection algorithm that classifies tumors as malignant or benign, or an animal regression model that identifies whether an image contains a cat, a dog, or a bird. Note that the first two examples involve binary classification because you only have two possible outputs, while the third is a multi-class classification because we have multiple possible outputs. And here are some examples of regression. For example, predicting the price of a house based on features like bedrooms and location, or estimating a person's height based on their age, gender, and ethnicity, or forecasting the temperature based on time, season, and humidity. Note that in all these examples, the possible output values are infinite, as they can take any real number.